holes are arguably the most fascinating and mysterious objects in the universe. Insane gravity, infinite density, really cool visual design. What else would anyone want? The gravity is so strong because matter has been squeezed into a tiny space. The gravitational attraction pulls so much that even light cannot escape its grasp if it comes close enough. Again, it was Einstein who predicted their existence in his field equations of general relativity back in 1916. Though the word black hole was first coined in 1967 by an American astronomer, John Wheeler. After decades of black hole being known as only theoretical objects, the first physical black hole ever discovered was spotted in 1971. Then in 2019, the Event Horizon Telescope collaboration released the first image ever recorded of a black hole. The telescope saw the black hole in the center of a galaxy M87 while it was examining the event horizon, or the area past which nothing can escape from a black hole. The image maps the sudden loss of photons or particles of light, which in turn opens up a whole new area of research in black holes. So far, astronomers have identified three types of black holes: stellar black holes, supermassive black holes, and intermediate black holes. But what do black holes actually look like? Black holes have three layers: the outer and the inner event horizon, and the singularity. The event horizon of a black hole is the boundary around the mouth of the black hole, past which light can't escape. Once a particle crosses the event horizon, it cannot leave. Gravity is constant across the event horizon. The inner region of a black hole, where the object's mass lies, is known as singularity, the single point in space-time where the mass of the black hole is concentrated, and at this point, every laws of physics are irrelevant. Scientists cannot see black holes in the way they can see stars and other objects in space. Instead, astronomers must rely on detecting the radiation black holes emit as dust and gas are drawn into the dense objects. But supermassive black holes in the center of a galaxy may become shrouded by the thick dust and gas around them, which can block the emissions from being detected. The Event Horizon Telescope image of a black hole in M87 galaxy was an extraordinary effort, requiring 2 years of research even after the images were taken. The next target is likely Sagittarius A star, which is the black hole in the center of our own Milky Way galaxy. Want to know more about black holes? Just subscribe and click the bell icon so that you get notified first about our new upcoming videos on black holes. You can also follow our social media handles through the links given in the description below.